It's what keeps us held to the surface of the earth and provides a sense of up and down. When we venture into space, orbit the earth, or some of the world, the force of the gravity precisely cancels out with a centrifugal force. The muscles used for standing posture and skeletal support are no longer used, and thus a torpede losing up to 20% of their mass, leading to severe medical issues. In a lot of movies and video games, we see a giant space stations constantly rotating to produce artificial gravity. But with the real world physics, is that even be possible? What would it be like living on such a station? How different things be up there? If we want to stay in space without any severe medical intervention and genetic modifications, we need some sort of artificial gravity. Then what is it? How it is produced? Let us discuss. Let's take a look what would happen if we launched a ball from a center of the station. Well, counterintuitively, it does not seem to go in a straight line. Now, let's try to launch it upward from the station floor. Instead of going straight up, it seems to be accelerated to one side. Curious, isn't it? Let's try to launch it forward from the top of the building, for example, and now backwards. Wait, what is this? Magic! Now, the ball is on the ground. What's going on here? To understand this, what is actually happening, we have to change our perspective on things. We are going to observe the motion of a ball from a stationary point of view outside the station. Starting with the experiment, we launch the ball from the center of the station as expected. The ball goes in a straight line. If we shoot it upwards from a station's floor, we can see that it also follows the linear trajectory. But unlike what might be the expected angle with respect to the local vertical, now shooting forward produces the result that we all expect. Finally, when the ball is launched backwards, when we observe that it is still forward, do you start to see the pattern? Now let's oppose the point of view for our convenience. Wow, it is really a matter of perspective. As you can see on the right side, the inertial frame, the ball behaves naturally. But according to Newton's second law of mechanics, states that the force is equal to mass times the acceleration. On the left side, you can see the rotating frame. We can directly apply this law without any modifications. Conceptually speaking, the same type of fed you can see it is absorbed. So now, let us look into an example mathematically. At what speed must the surface of the space station move so that the astronaut experiences a push on his feet equal to his weight on Earth? The radius is given 1700 meter. That's really huge. The radius is given as very huge. That will be is equal to approximately 18 football grounds. That's interesting. So let us take into account, we know that it all happens due to a centrifugal force. So we know the equation for that. Fc is equal to mv squared by r. So let us take that equation to solve this. So Fc is equal to mv squared by r is equal to mg, and we know that we are pretty smart and we know that v is equal to root of r into g. If we substitute the radius and the gravity, we'll get 130 meter per second. So the edge of this centrifuge has to be rotating at 130 meter per second. If we do that, the artificial gravity inside will be possible. So this is how the artificial gravity works.